Hey, hi.
आणि इथे पण आता तुला सांगायचं होतं की तू छान कन्व्हिन्स करूया लोकांना. त्या दोघांबद्दल कम्पेअर करायचे हे मला माहिती नव्हतं की त्या दोघांपेक्षा मी कशी पात्र आहे. तर बिकॉज मला ही थोडी दोघांपैकी वीक पण वाटते.
Hello. Hello. Good morning, friends.
Hello, good morning.
Yeah, very good morning. Okay, we'll continue. But see, yesterday from almost 110 to 120, I was talking. Uh, Network connection was gone, but nobody informed me. Okay, I was simply talking. Actually, the network guy, the Geo guy, was doing some repairs there at the pole. So he disconnected it. I am trying my proxy and all those things. Okay, no problem. So if anything, any connection gets lost, now please immediately call me, right? Because I will not getting responses quickly. Okay, okay, friends. If anything goes like if any voice is broken or uh, you felt that the network is broken, okay, okay. So okay, all are there present. Hmm. See, I am feeling it is a fourth day, but according to my course outline schedule, I am on the second day only, right? So I am with the impression that I am on the fourth day, so many things I have to cover, but actually it's only half day sessions. So it is not fourth day because I am with the feeling, psychological feeling that so many things are yet to complete. But it's according to my normal schedule of 8 hour schedule, it's actually a second day only. Okay. See, friends, JMeter is not that complex tool. The complexity lies in understanding your requirement to do the performance analysis, and the complexity lies in the technologies. See, from the first day I was talking about uh, HTTP, I was talking about some cache headers. Why? I can simply tell, if you go to any, like even to JMeter docs also, documents also, they simply say, because to implement the cache of the browser, we are providing you with the HTTP cache manager. To represent the cookie management of the browser, we are providing the cookie manager or headers. There ends his explanation. He will not talk about like how when we give an header, the performance will be affected. How by choosing different headers? Because here we are replacing the client. Okay, I don't want to again go into the details. I will come back if I need. We will proceed with the topics because still you have to understand cookie manager, cache manager. So again, I don't want to go deep into that and miss the other topics. Okay, so we will proceed further. Then we will come back if need arises. Okay. So yesterday, I think I have to share my screen. I hope you are all present and you are in the class. Okay. Ask questions, interrupt me, because I will be in the continuous flow. I will not be knowing whether the my voice is audible to you or whether my connection is there or not. Right. So if anything, if you feel like is not as going as required, you please inform me immediately. Okay. Okay. Now, yesterday we were discussing, actually in the last part of our session, I was explaining you about headers, right? Cookie managers and all. And I want to finish that, and I want to start give some introduction to timers and controllers and log and variables or something, but we could not do this part. Okay. So Anyhow, I will not go into this. I will come back to this. We will start with the timers. Okay. Okay. Now, see, I will highlight a topic of JMeter, but I have to jump again to the scenarios, technologies. Basically, the definition of a timer is to introduce gap between the activities. It is simply to introduce the gap between the activities, basically to simulate the real user behavior. So many times I highlighted JMeter will help us with the facilities to simulate the real user behavior, simulate the client process, and generate the load, collect the data, control the activity, control the data collection. These are the things. Again, I highlight here quickly. Okay. So it helps us in emulating real user behavior. Second, in emulating JMeter functionality helps in emulating the real user behavior, in emulating client process. Third, to generate load with minimum resources. You print this and stick before you till the class or till you practice the load runner. You have to question how JMeter is helping us in emulating real user behavior, how helping us in emulating client process, how it is emulated. Of course, this you might have understood, creating the threads, right? Creating the threads, ramp up, loopings. Anyhow, I'll explain you. So client process, like many things like post processors, config elements. Okay. In the post processors, I'll come to that. Client process and managing cookies. Of course, I'm just repeating. Config elements are cookies, headers, dynamic data. Okay. So real user behavior. Now timers, controllers, okay, and other things. And we should be able to control the activity and collect the data, logically control the data collection. We need, because some debugging facilities, scripting facilities, scripting or programming facilities. Parameterization facilities. And 10, data visualization. Okay, like graphs and results viewers. We have listeners. So these are the things which you have to understand. Okay, now we'll talk about timers. Okay, friends, these are the very important things. This is about JMeter. So you have to not only JMeter or any performance analysis tools like LoadRunner, Silk Perform, or anything. They have to provide us with the functionalities to perform these activities. And we'll talk about timers. Our intention is to create the load. That is the first intention. That is what we have. That is the discussion we have started with, to create more load with minimum resources. So we avoided the client. So what we did here, generate load with minimum resources means we wanted to exclude the client process. Very important thing. Okay, we exclude the client process. Because we excluded the client process, in the last 2-3 days we discussed about parsing, we discussed about cookies, we discussed about headers, and of course still we discuss about session IDs, dynamic data. These are all the functionalities of the browser. To generate more load on a single machine with minimum resources, we wanted to exclude the process. When we excluded that process browser for us, because we are using HTTP protocol, we started our understanding from the browser's point of view. It need not be browser, it can be any Java client or some other client. Many clients are there. So when we excluded the process, the functionalities we missed by excluding that process, we looked for some JMeters or JMeter functionalities to implement those. Okay. Now coming to timers. You have to understand these timers from 2 points of view. One is from data collection point of view. And real user behavior point of view. When a real user interacts with the client with some system, so you know, system means integration of many technologies. Technologies on which our application deployed. Okay, so when a client interacts, he sends a request. Then immediately he cannot do actions because he has to wait for the response. So when he sends the request, that request has to go using some protocol over the networks and to these servers and multiple servers, and your request should get processed on different units or of the functionalities deployed on our system. Then some response will be generated using different network protocols and application protocols, transmission protocols. The data will be sent to you in the packets. It will enter into your IP address. Then it will go into the client process like browser. This will create the graphical user interface using its own technologies. We don't call, so most of the times we call sometimes this browser as browser technologies. It has many technologies, right? Browser technologies. It is not a simple process. It's a very thick client. So wherever I draw a browser, I draw like this, a thick process, right? Lot of things it will do. It will do the parsing. It will manage the cookies. It will attach the headers. It will attach the certificates, right? It has the proxy informations, encodings, a lot of things, right? It has to play the video, audio, many applets, add-ins, so many things. JavaScript should be executed. So finally, it will create a graphical user interface. So a real user can interact with this. Now you can imagine the delay. From the time you send the request till the time you got the response, there is a time delay. Right? A real user has to wait. So you go to an ATM, you enter your card, then it will ask for the PIN number. You enter the PIN number, then you wait, then you get another interface, then you enter something, account, something like this. Now, you can see here, there is a gap between your requests. You want to implement those gaps. So timers implement the time gaps between client interactions. Okay. So we have timers. I got that. Let us do. You understood? The timer simply introduces a delay between the actions. Why we have to do this? Because we don't have the browser. Our intention is to avoid that browser process. We are not having that renderings, parsings, attaching the cookies. Such things are not there. We have implemented differently using JMeter functionalities. But if you want to simulate a real user behavior, we need some facility like timers. In load runners concept, or here also sometimes, timers, we call it as think times. Okay. There are different types of timers. I'm using 5.50 only, version of 5.50 version. Now, before it gets started, I explain you some more things. Now, let us think from the second point of view. First point is we want to simulate the real user behavior. So a real user waits for the response. So there will be delay in getting the response. So he will wait and act. Now, from the data collection point of view, now you have observed our script, JMeter script, where you have recorded with the proxy, you have recorded with Chrome extension. So you have recorded multiple requests, request 1, request 2, request 3, like this many. And in this you have images requests, JavaScript requests, CSS requests, other HTML requests, so many things in one go. You might have clicked one link, simply one link, but your browser might have parsed the HTML and found the resources. All the resources were requested. All was presented here. Now, when you replay this, all the requests, they all will be sent in one go. Understand? But this all didn't went in one go to the server when we really recorded. At that time, first one HTML came, then it was parsed, checked cookies, checked cache using if modified since headers. If the page creation requires some resources, it has taken from the local cache or it has downloaded. A lot of logic went. All these were developed in different timings. But when you replay it, it is going in one go. Okay, let it go. But what is the scenario or the system? All these requests will get lined up. And if the system is having enough resources, enough connections, all these requests will be processed within no time, which is not the case in reality. So if you want to simulate real users, of course, we will introduce timers. Now the question is, what happens if I send all these requests in one go? Rate of consumption of the resources will go high. Rate of consumption of system resources will be high. Imagine in your office canteen, normally the lunch time, say imagine from 12:30 p.m. to 2 p.m. Say these are the lunch timings. Say you have some 1,000 employees. Imagine like in school at 12:30, some bell rings. Okay. We all 1,000 enters into the canteen. What happens? Say we may have some 20 tables. On each table, 6 members can sit. Imagine. So at a time, only 120 employees can have the lunch. But what happens to this remaining 880 people? So many of us may turn back. We may go outside to some other hotel. So you cannot come and report that the canteen is not having enough food. Canteen is having enough food. Canteen is having enough resources to serve 1,000, more than 1,000 also. But which resources are consumed fast? Tell me, friends. Canteen guy is having the food to serve 1,000 people. But when all of 1,000 employees enters into the canteen, some resources were consumed fast. So 820 people have to wait in the queue, or they may go to some other places. So which resources are not available so that 820 people have to wait in the queue? Imagine and tell me. Hello?
Yes, sir.
Yep.
Which resources are not available now? Tables
So
might not be sufficient.
yeah, plates and
Plates
spoons
might
will
not
not.
be sufficient. Plates might not be sufficient. Right? So when many more activity happens in smaller time, rate of consumption of the system resources will go high. So many of the requests fail. So you will stand there, give me the plate. I observed in Infosys Bangalore Golconda canteen, we all have to wait in the queue, long queues, and intentionally those guys will be serving slowly. Of course, there are many canteens in the campus, Infosys campus, and we will stand in the queue discussing some project related things, other things. We will not feel bored. Slowly that goes, and one guy only was serving from that end to this end, all the items, not multiple. I was talking about in the initial stages, like some 10 years back or 12 years back. I observed why. The serving people are only one or two, and they are doing slowly. We are also not feeling bored. You go to some other canteen, there will be many people serving, many plates will be available. So we all will have the food, and we will be standing, searching for the place to sit, because it was not optimized for the resources availability. So here optimization of the resources utilization is important. Optimization of resources utilization. Optimization of the resources utilization. We have to balance, we have to synchronize optimization or synchronize. Okay. So what happens when the guy, single guy serves the food in the plates, by the time we have the food in our plate, somebody might have finished their food and they vacate the table. And again, another synchronization I have observed there is, there are no more plates. We have to wait for the plates to come from the kitchen after washing. So even if tables are cleaned, we will be waiting for the plates. So the problem here is, once you get the food in the plate, you should get the seat to sit and eat. It was optimized like that. Whenever you go there with the request, resources should be available. So this can be achieved with the timers by delaying. One more thing, if you go to some SBI ATM, or some other banks ATMs, ICICI Bank and all, you will not have any problems. Like you enter the debit card, then you enter the PIN, then you enter the amount, your money will be dispensed simply. But you go to SBI ATM, he will ask you to enter 25. I don't know why. I will explain you. Then he will ask you, is it your savings account or current account? He already has my information with my debit card itself. Then he will ask many yes or no questions. Then he will ask the amount. Then he will ask the denomination. Then after some time, he dispenses the amount. Why he do this? Because SBI is having many more customers than ICICI. In villages, farmers, everybody will have SBI. SBI Bank will be there in every nook and corner of India, right? So they all will try to use the ATM. So they cannot improve the hardware infrastructure to cater the many users, hundreds of requests. So intentionally, they will introduce the delays. These delays are to relax the rate of consumption of the resources. Consumption of the resources. Now, we also, to simulate the real user behavior, we have timers. We have timers. Any questions up to here, friends?
Nope.
Yes. Think. You think, no? I told you some things. If you know these concepts, then you will appreciate the functionalities of JMeter. We have timers. So the hero element in JMeter is the sampler. Okay, the hero element is the sampler. Yeah. Many things we have to discuss, some cookie manager properties, cookie policies. But I felt I am getting delayed in my topics. Actually, I felt it was fourth day. According to my schedule, I'm on second day only. So I had that feeling yesterday. I'm spending more time on many things. Okay, let us proceed further, then I'll come back. See, timers at different levels. We have test plan level. We have thread groups level, right? We have controller level. We have sampler level. Levels. Note these points. What are the levels we have? Test plan level. You open JMeter and see test plan level, thread groups level, controller level, and sampler level. So timers at different levels introduces delays between activities, which affects rate of consumption of resources. This is my wording, rate of consumption of resources. If you go and see in the document, they don't talk about this. They say, okay, you did to implement the real user behavior, your timer can be introduced. That's all. There ends their explanation. Why we have to do that? Right? Because we are collecting the data. So sometimes I would like to deplete the availability of CPU resources. Then I will check how the non-availability of the CPU resource affects my some activity. So I want to have the control over the data collection. Okay, so timers at different levels, test plan, thread group, controller, sampler. We will introduce first one, constant timer. Okay. So to understand these concepts, we will have some simple requests, right? Thread users, thread group. This is one group. How many users in this? Okay, I will put some 3 users. Each user can repeat the activity. I can give the loop count. I'll give 2. Why we have to ask them to repeat? Because of the statistics reasons. We want to collect the data. To arrive at a statistics value, we need more value, because statistics is based on frequency of the occurrence of the data over the total occurrences, frequency of occurrences. Sometimes it's called probability also. If you flip the coin 100 times, if heads came 20 times, so here 20 by 100 gives you the probability. Finally, remember, statistics give from your data, from the large data, huge set of data you collect, it will reduce your understanding to a single value, like average, mean, median, variance, standard deviation, right? Means it will reduce the whole data for you into a single value. That is how the statistics works. Other statistics is there. Probabilistic statistics or Bayesian statistics, where it predicts. Okay, that is a different thing. Here also sometimes I referred here is, now I will tell you what is Gaussian. Gaussian timer is there. Poisson timer is there. Uniform random timer is there. Wherever randomness comes, there is probability. Wherever the randomness comes, there is some distribution. So in reality, there will be some randomness in our activities. So JMeter also supports with some randomness in its elements. Okay, now we'll see that later. Then I'll add a simple controller. This simple controller, we have understood, it is only to organize or group the samplers or other things. So I add into this a sampler HTTP request. Okay, HTTP protocol. If I don't specify also, because the DNS server will resolve blazedemo.com. See, yesterday and all I added HTTPS. I'm adding this, and I will use the simple path. Yesterday we had the understanding of what is redirect automatically, follow redirects, right? Keep alive, I have not explained to you. I'll do that. Now I will add one viewer here, listener, test, finish. Now, if I run this, see how it runs. There won't be quickly it runs. HTTP request will be executed. How many times? 3 users are there. 2 times they will repeat. I'll run this. I'll save this. timers demo. You may argue with me, we are seeing delays. Yes, it is waiting for the request to get completed. That is the normal communication delay. We will measure it later. Okay. Now, what is there here? It is directed to some other. Okay. A request is directed. See, it is directed to HTTP. I typed only www. From there, it was HTTP. Then from there, it was directed to HTTPS. Okay. We will discuss. We will not discuss this. Now we are concentrating on the timers. Now I replay this again. Run this. This time it might be slightly faster because some resources already might be downloaded. Okay. Okay. No, it is the same. Why I have not implemented cache manager here? That topic we missed yesterday in the last minutes. Okay, I was explaining connection gone. So I'll explain you again. So browser generally checks for the cache cookies. So some delays will be there. But here, the browser is not there. I have also not implemented any header manager, cache manager, cookie manager, which if I had implemented, it would have simulated the browser behavior of managing the cache and attaching the resources, so many things. But this delay, what we are observing, observe again. See, some gaps are there. Okay. Now I do one thing. I introduce another. I just copy this. Copy, paste. Control. I can use Control V also. I am having this many requests. Okay, no, later. I will show you later. We will use loops only. Okay, now one request is there. Now I am running this with 3 users. Threads means 3 users and 2. Now let us introduce a timer where let us introduce at the thread level. Add one timer, constant timer. And let us add this to 1000 milliseconds because he is asking in 1000 milliseconds. Constant timer at group level. No, at see for the dotted line, this is at the group level. Okay, means this applies to all the elements. Simple controller is an element. HTTP request is an element. Okay, so it applies to all at the group level. 1 second. So I'll run this. Now see, one request goes, still it has not started. Observe. See the delay, observe. See what is happening. First delay is applied, then the request is sent. Not after the request delay is happening. First delay happens. First JMeter calculates the delay. Then it executes the request. I am sending it again. And sometimes you are seeing only one request. Sometimes you are seeing multiple requests because threads are running in parallel. Note this point. We are running threads. They are not running in sequence. They are running in parallel. So all 3 users, they started sending the request. One user got the response quickly. Other 2 users got the response together. Sometimes all three may get the response. To see this, I'll increase the loop count to 5. Running this, see. Depending on the resources. But now they are in loop. What I did, I only increased the loop, but threads are 3 only. So loops are getting executed in sequence. Now, friends, you have to understand all these things. Now I increase. I told you just now some important point. After increasing the loop count, we have not seen that difference in the responses. Same 1 or 2, 2, 1 are going on. That is because looping means executing in sequence. A user is given a script. He was asked to repeat the script 2 times. So he will execute the script once, then he will go to second. So looping is not parallel. Looping is sequence. Threads are parallel. Note this point, okay? Thread groups settings. See, threads are users execute the samples in parallel. Looping is sequential. Note this point. Okay. Now increase the threads. Means parallel activity happens. I make 10. I am making 1 loop only. Clear the. See, I have not explained you the user interface. You can understand. This is for clearing. All, clear all, right? This is clear. Only that specific thing which you choose. Okay. Now this is run. Start. Okay. Now. Run. See this time, how many at a time, many requests happened. Didn't happen every time. Okay. Observe again. That depends on the resources availability, because Blaze demo is somewhere outside. A lot of things matters. Okay. Now see sample result. So all are successful. Okay. So you can see the timings. Load time 798, connect time 31. Latency means to get the response, we will be waiting. Right? It is sometimes we will dial the number of our friend's phone number. We will wait till he picks up. That is the latency. We have reached to his phone. It is ringing. Okay. Or we asked somebody a book. He will not immediately give the book. He will act to give the book after some time. It might be besides him only. He might be doing some other work. When you ask, please pass on that book, immediately he may not give. After a delay of few seconds, 5 seconds, he may finish his job, or he may slowly understand your request. He may have attitude, some things. So that is the latency. So, and what are the, how many bytes are sent? Okay. So these things. Now we are having the timer at the
I have one
group
question.
level. Yes, please. You're asking something.
Yeah. So as you mentioned about the load time, so this load time includes the delay that we mentioned in the first place, like 1000 milliseconds, or it is
No,
the time that we get the response from
no.
server?
Load time means you are after your page is first byte of the page is received.
Okay.
Right.
Yeah.
And you will be requesting many resources, images, some video files, and all the advertisements, all will be, your browser is making requests.
Yeah. Right.
So your page load time. So response time is connection time, latency, and load time. All three together is the response time. Got it?
Yep.
Understood?
So yeah. So load time is the first resource which we received.
Not
Then the
first
load.
resource, not the first resource, the total page loading time.
Yeah. So the total page loading time will be the load time, right?
Hmm. So what we
So
will see that we started the clocks. Let us say we started the clock. Now we send the request. Clock is going on. Now it has gone through the network and it is in the system, gets processed. We receive the first byte, let us imagine. So till this time, so first is connection time. I will go here. I will wait in the queue for me to get connected. That is the connection time. After connection time, what happens? We submit the request. Submit the request. Then immediately I will not get the response. It gets processed. That is the latency. So
yeah.
connection time, after connection time, I'll get the first response. That is the latency. So from here to here, connection time plus latency. Then first byte, then I will get all the page related resources. This is the load time. So
Okay.
connection time, latency, plus your total resources. And different tools, sometimes they, till the first byte, they say response time. You have to understand what that tool is giving, right? Okay. So connection time, latency, and total load time.
Right. To receive all the to get the all
Hmm.
resources on the web page.
Yes. And this doesn't include your timers which you are introducing. You have to note that.
Yeah.
These timers are here. We are in sending the request, we are delaying to relax the resources utilization or to simulate the real user behavior.
Yeah. So we can use JMeter for to get the particular load time of the web page, right? Like
Yes,
we are
even a
getting.
particular resource also. Now you are coming to the point. Yesterday when we recorded, we spent a lot of time with embedded resources also. So
Right.
normally with Selenium, I can start the clock, current time in milliseconds, I can start and I can measure the time taken. But I will be measuring there the actions. But if I want to measure how much time a image took to download, will
Right.
not be possible. But here, if I record the resources, I can identify a request for the image. Around that, I can put a transaction controller and I can measure only the time taken for that image or part of the page downloading. Whole page downloading I can do, or part of the page downloading I can do. So yesterday in the proxy recorder, we are having something groupings, how to group. So each group can be a transaction controller. Means we will measure whatever we want separately. See what happens, again, another thing you should get the imagination here. See, first we made a request, Blaze demo. We received 1.html. 1.html. So okay, one.html. Okay. Now it got parsed. What is the second step? It gets parsed. Now, when it gets parsed, what happens? All the resources required for this page will be sent to different URLs, through different URLs. Who does this work? Browser will do this work. Then Imagine. So for all this page, one set of resources were requested. This is one set. Say 10 resources, 10 URLs were requested. Then in this 10 URLs, one URL is 2.html. Now this 2.html is parsed. In this, 3 resources are required. So these 3 resources will be requested. Then again, in this, another HTML I may receive, which is 3.html. And parallelly, in these 10 URLs, 2.html is one, there might be another 5.html. So this 5.html also, when parsed, it has the resources. So something like 7 resources. So like this, these groups of resources are getting requested. So these groupings we can do, that is the setting in which you have observed, of course, not concentrated much on that, in the script recorder, HTTP script recorder. One participant, she observed, right, the groupings of the resources, right, how to group, like what delay we have to give between the users. There are some settings there. What happens? Why these settings? Always question yourself. Why? What happens if I group, if I don't group? If I group, what happens? When I replay, all this will be requested in one go. If I don't group, what happens? Because in my script, all the resources which were requested, these 10 URLs, then these 3 URLs, then these 7 URLs, even though they were requested in different timings, because in the script I am having, say, imagine we are having one simple controller. In the simple controller, all the requests were recorded. So when I replay, all the requests will be sent in one go. The activity will differ there. You are observing. In the real scenario, all are not requested at this in one go. In different timings, it got requested. So to simulate that, we are having in HTTP script recorder to group the embedded resources. How to group, how to choose the transactions. Means our main objective is to generate load, collect the data. These are the only objectives. What are the objectives?
To generate load and collect the data.
What are the objectives? Generate load. Collect data. I told something, I missed it. What I
Read,
told? Object. Huh?
read responses, measure time.
Okay. Okay. Measure response. Create activity. Measure responses. Measure the time taken. So this time taken for any activity is a measurement of availability of the resources. Time taken is actually availability of the resource. This reflects the availability of the resource.
So there will be multiple factors affecting the load time, like bandwidth
Yes.
and number of users like accessing that
Yes.
particular web page. So
Yes.
can we have the capability to like get the average like sampling size of that particular page load time? Like we have to load the page 10 times and we can get the average time taken to load the page to get
Yes.
the actual.
That is what that telemeter will do us. It will collect the
Okay.
data. It's a time series data. So we may start. That is the discussion we started, right? Why we need more number of users? Why we need to loop it? Because I would like to collect the time from 9 o'clock to 10 o'clock, some activity.
Yeah.
So I will go in loops. I will go with multiple users. I will collect the data. So once I get the data, I will average it. And
Okay.
I will not get one user. If I run parallelly 100 users, at least there is a chance that at any point of the time, I get 40 users sending me the data, right? Imagine you have hired some 100 users. You send to different ATMs in Pune. So 100 users, they started withdrawing the amount from 9 o'clock. You wanted to measure the time taken for withdrawal from 9 o'clock or 10 o'clock. So all these 100 users will be performing the activity. So you will give them the clock. They will start the clock before inserting the ATM card. The clock will be running. They will be interacting with the ATM. Once they receive the amount, they will stop the clock and they will report you. Now imagine out of 100 at 9:10, how many may report the time taken for their activity? All 100 cannot, right? Because all will be interacting with the system from different locations in different timings. So they get different resources. So the time taken for that activity will be different. Some might be dull users also. They may interact slowly also. So all 100 users will not send you the time taken for the withdrawal activity at the same time. So in the first chunk, after 10 minutes, 10 guys may send. So at the same point at 9:10, 10 values you will receive. So you can average it. Now, after at 9:16, 20 users may send. They might have finished at 9:16 the transaction. At 9:17, 50 users may send. Then at 9:20, only 2 users may send. You see the distribution now. This is a random distribution because availability of the resources is random.
Yep.
So the amount of users who completes the transaction from some point of view, it is random only because the availability of the resources, almost it is random. So statistics depends on its calculations on randomity. Even if the randomness is not there, we introduce randomness into it. Now you will see random timers also. Now, let us go back to our timer. See, simple timer, we are discussing so much things. All are important. Simply, I can say introduce a timer, it will get delayed. No, that will not help you. Okay. Now, I will add another timer. This time, right click, add, right click the sampler. I am adding a timer, constant timer only. This time, 2 seconds. Sorry, 2 seconds. Now what happens? Before executing this HTTP request. So who is executing? Users. How many users? 10 users. So I'm giving this script to 10 users. So this user will try to make this request. How he will make? He is controlled by this timer. How much time? 2 seconds. And also there is another timer, right? What is this timer? 1 second. So this timing, which is at this level of controller, and the timer, which is at the sampler level, both gets added. So this is 1, this is 2, 3 seconds holding will be there before sending the request. Let us replay and see. All 10 were released. You have to observe this. You can question me. You told something, but it did happen. 10 users parallelly are there, right? How many loops are there? Only 1. So 10 users, they started. I have given the copies of the script to 10 users. They did a lot of other homework and all. They were ready to execute the request. But all were asked to wait 3 seconds, then submit. That is what happened. See? One user or 2 users they got the response. It's all random. We cannot predict. That is why we go by the frequencies or statistics. Okay, see? 3 seconds. It is waiting. All are waiting. Now 2 gone. Finish. That, see, sending the request is in our hands. Getting the response is not in our hands. We all can hold and send the request together. But the completion of that request may take different timings. Okay, I'll do one thing. I will add one more at the test plan level. Add timer. This time another 3 seconds. Now, HTTP request will be executed with the effect of all these timers. See, this constant timer, see the dotted line. Of course, we are having the separate discussion of this scope hierarchies. So thread group. So all samples in this thread group will be affected with this constant timer. Then at this controller level, there is one timer. So all these samplers inside this controller will be affected with this timer. So this timer plus this timer plus the constant timer. So this constant timer, all three will be added, and the total time delay before executing the HTTP request will be the sum of all the timers in the scope of the request, in the scope of the sampler. Okay. So test plan level, thread group level, controller level, and sampler level. How many we have? Test plan level, thread group level, and of course, I didn't add at the sampler level. I can have sorry, controller level. So I can add one timer at the controller level also. Controller level and the sampler level. Add this. I will introduce you with more timers. Do it fast, 5 minutes. Understand the concept, simply not adding. Observe the dotted line. And you because you are all testers, you assume, you imagine with this timer how the response should be. Are you able to see any difference? See now, see. All are waiting for that many seconds. All will be released in one go, but the completion will happen in different timings. Now I'll do one thing. I will loop it and see. See the difference will be there. Looping. I will reduce this to 5 users and 5 users. And I loop 5 times. Okay, now run. Again, they came. They are in the loop now. 5 users, they are all waiting. So they submitted. They are waiting. Now see the difference. Observe. Note. 5 users. They are going in loops, 5 loops. So all are given the script. But before executing the script, they all have to wait. Now I add one more request after this. I will add one more request. So this is Blaze request. Okay. Blaze request. I will add one more. This time this is google.com. Don't run google.com for multiple times. He will block you, right? For one day, he will block. So now this, I name it as a Google request. Okay. So 2 requests are there, where both in this controller. But for this one Google request, I don't have a sample level timer. This is having sample level timer. Let us run this and see. All 5 users are given the script. They are all waiting to perform. Blaze request happened. Then all are waiting to perform Google request happened. Then all are again, they went in the loop. Blazor request, then all. You understand, samplers and controllers, they are getting executed in the order. To do this, friends, introduce the timers, different level timers, multiple requests. You play around. Understand first why the timers. To introduce delay between the requests. Why? To simulate the real user behavior, because in the reality all requests will not be made in one go. And another thing is, for analysis purpose, for performance analysis purpose, I would like to consume the resources like CPU resources, the network resources, and I would like to see how that non-availability of the resource affect my activity so that I can analyze. Do this, friends. We are learning timers. Okay. We will see many timers are there. घंटा तक खाना नहीं खाना, मैं 15 मिनट क्या खाना है? क्या? Any questions up to here, friends?
No.
Yeah, you are able to observe the effect of timers, right? At different levels. Now, many times I said, like, the data we collect, we process using statistics techniques. But just now, few minutes back, I told you statisticians require randomness in the data collection. So if normally data will be random only, but now we are using JMeter, we are simulating the real user behaviors, but that is not a real environment. So we need some facilities to introduce randomness in that. Normally, if we go and withdraw amount from the ATM, the time taken to complete the transaction depends on many factors. So almost that is random. We cannot predict. It takes 2 seconds, it takes 3 seconds or 5 seconds, but some distribution will be there. Say from your Pune station to Hinjewadi, on an average, that's mean time, right? On an average, let us say it takes between 9 o'clock and 10 o'clock, something like 50 minutes. I think it takes more. For example, you take, okay, 50 minutes. Some may come with some variance. How much variance will be there? Okay, instead of 50, I will use something like 1.5 hours. Means 90 minutes. Average is 90 minutes between 9 o'clock and 10 o'clock. Because heavy traffic will be there. Now, all will not take 1.5 hours, right? All will not take 90 minutes. Some may take less time, like 1 hour, 15 minutes. Some may take more time, 1 hour, 45 minutes also. So, if the average is, we have understood on the first day itself what is average, the value which occurs most of the times. So, if you have a time like this, say this is 90 minutes time. This 90 minutes we arrived at with the distribution of the values. See, in the normal distribution, it will be like this. Means, if this is the deviation, standard deviation, how much deviation will be there? Some plus 15 minutes, 15 minutes. So most of the values will be in this section. This is called Gaussian curve. This guy observed that any data collection or some activity always will be around some value with some deviation. This is sometimes called normal distribution also. Very local, normally we'll say bell curve. So normal example they give when they try to explain Gaussian is student's height in the class. Student's height in the class. If the average height is 5 feet. So if you plot, if the average is 5, most of the students will be around 4.5 feet or 5.5 feet. Some will be there 6 feet, very less. Some less than 4, some will be there. 3 feet, very low will be there maximum. So your Gaussian curve, or if you plot the data, the distribution of these values will be randomly distributed in this pattern. This type of distribution is called Gaussian distribution. Now, our statisticians want our data collection like this. Okay. So they wanted the distribution like this. So we have Gaussian random timer. So what we do, what is the randomness we are choosing here? the resources availability. Here, not that I am sending the request. Why I want to send the request? Because I want to sample the resources information in different way. So I want to group my data collection around some mean. So like bell curve, most of the values will be around mean with maximum deviation, standard deviation. If the constant delay offset in milliseconds is 500, constant delay of means, for example, this is, I can say it is mean. And if the deviation is 100 seconds, so the random delays will be 500 plus or minus around 0, and the values will be like this: 505, 590, 450, around 500. So if you have something like this, okay, first I'll show here. So let us add one timers. Under timers, we are having one. Where is this? Gaussian timer. Okay. See, deviation in milliseconds means this is the standard deviation. For the heights, we had almost 1 feet this way or this way, 5 feet. So 4.5 feet, 4.5 feet or 5.5 feet. So that is the deviation. And constant delay offset is average. Okay. So now if I put this, like if I have, for example, 500 milliseconds like this, the meaning will be 500 milliseconds here, 500 milliseconds, and up to here 100. Sorry, this is 400, this is 600. So these are number of users. Number of data points, I can say. So if you draw, most of the values will be like this. This is how I wanted to distribute my data collection. So I will get data like this. I want to analyze between this time and this time. If the distribution of the users delays are like this, the statisticians may get some different inference. Okay. It is not zero like this. Slowly it will go. Some guy will be there who reaches in 2 hours. I would not like to say. Somebody might have started most of the times 1.5 hours, less than 15 minutes, 15 minutes less or 15 minutes more. If somebody comes and tell we took 3 hours to come from station to Hinjawadi, by walking also we can come in 3 hours, right? So those are all outliers. We don't want to consider. If somebody says that I started at 9 o'clock, I reached Hinjawadi in 20 minutes, impossible. So he might be wrong data, he might not have understood. So we will not take the data. So we will consider some data. The valid data will be here in our case, our statisticians will choose. So this is the data. This timer we can implement this timer like this, right? This is a Gaussian timer. Whatever timer, all timers will be added. Okay. So now you create a new script and see how the timings. I'll do one thing. I will add these to the controller level here. I can hold and I can pull at this level. So all constant timers I disable. I nullify their effect. Disable. 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 Now I am having only Gaussian timer. How many users? 5 users. So the delays will be applied but differently it adjusts. Total maximum, how much delay will be there? I will increase. I will have maximum delay of 3 seconds, and this way or that way, some, if you want to observe, let us have 2 seconds. And here it will take more time, even then 5 seconds. So approximately the delays will be from 4 seconds to 7 seconds. That is the meaning of this. 4 seconds to 7 seconds. To really infer, it is very difficult. What I have explained you, that's the thing, because the delays will be grouped around 5 seconds with the variation of 2 seconds, this way or that way. Means some may take 7 seconds, some may take uh, of like 3 seconds, but most of the values will be grouped around 5 seconds. Why we wanted this? For statistics purpose. Because in the real environment, because what is our intention? To simulate the real user behavior. This is our objective, right? Our objective is to emulate the real user behavior. Real user behavior in the reality, the time taken for any activity will be random. So we are introducing timers. Of course, we are having controllers and so many other things. So first we are starting timers. Okay, friends, you implement this, understand this, okay? Many really will not understand these points. They may talk more about JMeter. You introduce timer and you introduce controller, if controller, welcome. Why we need this? That is important, right? So practically, if you do, then you will understand. Then you appreciate the JMeter's features. Otherwise, simply you create a thread group, you add some things. That is what in YouTube and all they will explain, right? And you run it. The whole JMeter, if you ask me to complete like that, I can finish in 1 hour also. Nothing will be there. But how to make use of this? That is why we are spending time in understanding different functionalities. So just a simple concept of timer, almost we spend half an hour. Some more things are there. Okay. So understand. Let us have some break of 10 minutes. Okay. I'll be back. So I'm back, friends. Now, we'll proceed further. You're all there? Hello? You note these 10
Yes. Yes. Yes.
you note these points. That's it will help you in understanding JMeter or any performance tool. These are the main functionalities which we also have to understand. So we are understanding timers. Last 3 days we understood about the technologies, protocols, recording, representation of the activities, so many things. Okay. Now let us see what is this. So whenever you come across Gaussian or normalization or bell curve, this is the concept there. Okay, where we will have some standard deviation. Standard deviation means name itself. Normally heights in a class, the heights will be, if the 5 is the mean, maximum half feet this way or half feet that way. That is the Gaussian distribution or normal distribution. That is the normalcy observed in the nature. Okay, if you plot all the heights, you will get the Gaussian curve only, the bell curve only. Most data will be around the mean, and the other outliers, the 6 feet guy will be very rare, and less than 4 feet guys also will be less. So this gives you some idea. Okay, the naturality, natural distribution. Now, uniform random timer. Here also this is random only. I also have to understand many things are there. This timer pauses each thread request for a random amount of time, with each time interval having the same probability of occurring. Okay. So here, I'll just so we wanted to randomly, but with equal randomity. Means 10 seconds, 20 seconds, 30 seconds, 40 seconds, 50 seconds, like this. So 5 users. Initially, this is 3 users, then 5 users. So what it will arrange is with 10 seconds and 20 seconds delay, with 30 seconds delay, with 40 seconds delay, with 50 seconds delay, same number of users, same number of requests will be sent with these delays. Same amount of requests will be sent, okay, with these random delays. Delays are random. For example, I have chosen 10 seconds delay. Out of 50 users, I will distribute this 50 among these 10, 20, 30, 40, 50. All will occur randomly. But the amount of users for 10 seconds with 20 seconds, 30 seconds will be same. So uniform random timer. This is what is explained there. I will not dwell more into this. You have to update yourself with the statistics, right? So for example, if maximum random delay is chosen 100 seconds, it generates numbers from 1 to 100 with almost equal probability. If 10 milliseconds is generated 5 times, 20, 30, 50, all will be likely generated 5 times in a time duration. To this generated random time, you can choose to add additional pause with constant delay. So let us see what is there. Right, add timer, uniform random timer. So random delay maximum is 100. Means no random will be there above 100. So all will be, imagine like 10, 20, 15, 30, 40. If they were randomly chosen, for those random delays, equal number of users will be distributed. Some algorithm will be there, they will, and to that random, which we have chosen, constant delay offset can be done. I have not given here 0. So basically understand, you need randomness for statistical purpose. So to simulate the real behaviors of the users, the random utilization of the resources in the system is the normality. Actually, randomly they will be utilized with the random users. So we want to simulate that random data collection, random user activity. So we are having these timers. So with the timers, what we can do, the rate of consumption of the resources we can affect. So the rate of consumption of the resources between 9 o'clock and 10 o'clock will be different. Between 9 o'clock, between 10 o'clock and 12 o'clock will be different. So the availability of the resources changes. All right. So to simulate that type of environment, we have these timers. So what more timers are there? Synchronizing timer, I will explain you. This is the important thing. Okay. There are many timers, okay? You can see here, right click. Many really I have also not used because they're all related to statistics only. See. Poisson random timer is there. Means you can choose a value. Most of the values will be around that value. That is the Poisson random timer. One more thing, see. Let us now learn how to refer to JMeter documents. Okay. You also have to refer to the JMeter documents. Anybody who wants to learn, they will go to this jmeter.apache.org. Type this. jmeter.apache.org. You click on this component reference. On the left hand side, you have component reference. Elements or components, the samplers. We are working with HTTP request. If you want to know about this, click on this. We have used only one controller, simple controller. We will be using many other controllers. Today and tomorrow, we will be learning the controllers. And listeners, we have used only one view results tree. And we have used a cache manager, HTTP request defaults, cookie manager. Still, yesterday you missed, I will explain you again. All right. And the counter, we will see. These are all the configuration elements. Assertions. We will check the response and check whether this is what we expected in the response. And we are learning now timers. Constant timer, Gaussian timer, uniform random timer, constant throughput timer. I'll explain you. Click on this. So if I want to have for 10 minutes, only 10 users. So you may run 50 users threads will be there, but in 5 minutes or 10 minutes of time, you want the load of 10 users only. So this controlling you can have with the constant throughput timer. So target throughput on samples per minute. We can choose this. Okay. I will add this. This is constant. You also read. This is how this is the timer introduces variable pauses to accommodate, because one more thing you have to note here, you can control sending the request, but you cannot control how much time it takes to get the response. This is very important. I can hold the users and then I can ask them to start interacting with the application at 9 o'clock in the morning. But the job which is assigned to them, they will complete in different timings. The different timings in completion of that job depends on availability of the resources. And we can imagine the availability of the resources will be random. See, you are going in the traffic. You will see a yellow signal. It will change to red. We all Indians, we know if the yellow signal comes, we will raise more the accelerator. Normally, that indicator is we have to slow down. So once we see the yellow light, we try to cross before the red light comes. We would like to cross the signal. That is what we do in Hyderabad, at least, right? So we wanted to check if you see, observe, say we 10 friends are going in the bikes. So we will see the yellow signal. Some will cross, some will brake. Once they act on that event, yellow light, some will pass the signal and they will go far. And once we get the green signal again, we will start our bike and go. So there will be different. We cannot say like whether we will get stuck at the red light or the others will get stuck at the red light. So there will be randomity. The availability of the resources will be random. So in this randomness, if you want to have a control over the activity over a period of time. So I wanted to control only 10 requests in 5 minutes. So I want to hold. What I have to do, I have to introduce the timing. So 2 users are in completion. So I will reduce the timing. All right. And if these guys completed quickly, there will be an algorithm. He will add more users. Okay. This is actually a goal-oriented scenario of load runner. In load runner, we can schedule. The goal should go up like this: 10 users per minute. Maximum it should reach 50 users. Then they have to ramp down. So this constant throughput timer is the goal. We wanted to have a load of 5 users only in 10 minutes, something like that. 50 users in 50 users should complete their task in 5 minutes. That again depends on the response. You cannot have unrealistic goals. Okay. So here I'll disable this, and Blaze and the total request. These requests are there. So at the simple controller, I will add a timer, constant throughput timer, and target throughput in samples per minute. It is decided on per minute only, the algorithm. So I will say 5 users in 1 minute. Calculate the throughput based on this thread only. How many threads are there? 5 threads are there. But I wanted to, this Gaussian timer also I disable. Constant throughput timer 5, and I will take for all active threads in thread group. This count 5 users per minute from all the threads of this group, not only the single thread. Okay, I will choose this. Now, what is the meaning of this? In a minute, whatever timer delays he introduced, it should approximate to 5 per minute. Run this. It will wait for 5 minutes now. Delay. Sorry, 1 minute. So in 1 minute, 5 users. This is the throughput. Considering the users from the group, means all threads. So because the minimum is 1 minute only, we have to pair this. So in the next minute, 5 users. And in between now you can have many other timers also. That and these all together will have an effect. Now it waits for another. In a minute, 5 are completed. See, Blaze request now it is not by the request told any number of requests. Any number of requests. Five requests we have chosen. This is the constant throughput timer. Okay, so it is running. Precision timer is there. Many features are there in the precision timer. The important is synchronization timer. I'll explain you. I don't have a slide on precision timer. See, this type of trainings which depends on many features also will become random depending on the requirements, the like training objectives, the focus on the topics will change. It will not be like any language where first we teach about types, then some if controller, this like that. There will be a flow. In JMeter, mostly the tools, because there will be varied applications with these tools features. So the training perspective will change from the requirements point of view. Of course, overall, like we are having like constant throughput, we'll try to cover all the topics, but focus will change. Okay, so the trainer will understand the requirements, and based on that and based on the inputs he gets from the participants, focus. I think in earlier, I didn't focus on precision because I just leave here because I will be having many topics. So I will just introduce, okay, this type of timers are there, you learn, right? So the basic idea from my point of view will be to make it clear to you that timers affect the rate of consumption of the resources. And this type of timers with randomness is required by the statisticians so that they will arrive at the statistics value. And for those reasons, these timers are there. Okay. And constant throughput timer is there. So this is the big timer, actually precise throughput timer. The timer to do variable process like constant timer, calculated to keep the total throughput, example in terms of samples per minute, same as that only, as close as possible to given figure. The timer does not generate threads, so the resulting throughput will be lower. Okay, take this as an exercise, right? See, so many options are there. Number of threads and think times, testing. If I start discussing this, it will take easily 1 or 2 hours with all exercises. Okay, now I will go through. Remember this. Basically, this is another type of timer, constant throughput timer. We can change this with these things. Okay, I don't want to spend. Just I am introducing you. So when the need arises, you try to implement these things, right? We will now discuss about synchronizing time. Up to here, any questions? Friends, you are following me. Are there any connection issues like yesterday?
No.
Yeah, okay. You just immediately call me because yesterday I was talking for 15 minutes. Nobody informed me. Okay. I also tried thinking that we changed that proxy, right, for Edge, because that proxy setting is at the computer level. Actually, I reverted back, but I was trying that I doubted my proxy settings are not allowing me. But actually, the Geo guy has disturbed near the pole, near the junction for 10 minutes, 15 minutes. He was giving a new connection to somebody, so he disturbed all other connections. Okay, that's
Uh,
again. Yes, right. Yes, please.
can you please tell me the difference between this constant timer and constant throughput timer?
Constant timer just introduces the delays constantly. Like if you choose 3 seconds
Mm-hmm.
before sending a request, it will wait for 3 seconds and send.
So per request, 3 second delay.
A 3 second delay. Before sending, it will wait 3 seconds. And again,
Mm-hmm.
depends on other, if you have many other timers, this also will be added to those timers, right?
Correct, correct, correct.
And constant throughput timer means, for example, in 10 minutes, you want to perform only 5 transactions.
Mm-hmm. You are not
We
audible.
start hearing, yeah.
I informed him through call, so he's checking his connection.
Okay.
Yeah, thanks. Informed. I was just talking only. Yeah. Now, so the question is, what is constant throughput? difference between the constant timer and constant throughput timer. Here, the constant throughput gives us how many number of users over a period of time. Constant timer introduces delay. Simply, if I say 3 seconds before every request, 3 seconds delay will be added. But here, the delays have to be calculated so that in 10 minutes time, only 5 users complete the transactions. So if 2 users completed the transactions in 6 minutes, another 3 users have to complete the transaction in remaining 4 seconds, right? 4 minutes. So the timing automatically it will calculate dynamically and it will see, because always it will not achieve, but maximum JMeter will try to accommodate only 5 number of users in 10 minutes of the time by introducing randomly different delays. You understood? Friends, you asked something like constant throughput timer, right?
Yeah.
Got it?
My understanding was actually, suppose there are 10 users in the thread group. I mentioned 10 users, okay? And in constant timer, I added 3 seconds, okay? So
What is that 3 seconds? There in the constant throughput timer,
no,
you
no,
will add
I'm
the number of users also.
in the
See,
constant timer. I'm saying in the constant timer. First,
in the
I'm
constant timer, see,
timer.
what's a
Yeah, if I
constant
added
timer?
3
Yes, constant
seconds,
timer.
so for after
Yes.
each thread means there are 10 threads. So for after first thread, there will be 3 second gap. Next, a second
No.
thread.
That is wrong.
Hmm.
Before sending the request sample, before executing the sample, that delay will be there. See,
Before
for
executing.
example, in my case here, 5 users are there. And 5 times they execute. Now, how many times they execute Google request? Total 5 5s are 25 times that will be executed by these 5 users, right? Understood? Yes or no?
No.
5
Can you please
users.
share me your screen?
Oh, sorry. Sorry, it is not shared. 1 minute. See, here I'm having Google request. Let me remove this also. I don't want Blaze request also. I disable this. So I am having only Google request, right? Google request. Now, what is the configuration? 5 threads, 5 loop count. So Google request will be executed how many times in the total scenario?
25.
25. Means Google request will be executed by how many users? 5 users.
5 users.
Now, if I use the constant timer, means if I say this is, if I say here it is 2 seconds. Okay. So 2 seconds delay. How many requests? 25 requests. Let us take approximately each request will be completed in 1 second. Each request will be completed on an average in 1 second. So for the total scenario to complete, how much time it will take?
25.
No. 25. And for each where we have added constant timer, right? 2 seconds. So each total 25 requests are there. But to execute each request, every user will wait 2 seconds.
Correct.
So 25 into 2, 50 seconds. Plus to complete each request 1 second.
75
so
seconds. 75.
Yes, 25 into 250. That 25, 75 seconds it will take. That is the constant timer. Understood?
Yes.
Here we are not restricting the number of users and number of iterations. We have just given the delay. Now, if I restrict this with a throughput timer, for the same setting, if I put this whole in I will introduce a parent, insert a parent. Okay, I will institute what constant throughput timer. What is that called? Throughput controller. So it's a controller, sorry. Okay, throughput timer, right? If I say throughput timer, it will become simply complex, constant throughput timer now. What this will do is, if I choose, I have to execute only 10 users. Totally, how many users are there?
5.
25 users. Sorry, 5
Okay.
users only. No? Sorry. Constant throughput timer. Why I have added again? Okay, delete this. I want to constant throughput timer only 2. In 1 minute, I want to execute only 2 requests. That is the meaning of this.
Correct.
Okay.
Hmm.
Now I run this. So how much delay I have to give? You can calculate now. If it is taking something like 20 seconds for each transaction, so in a minute, if I have to run 2, the 20 seconds minus that remaining for how many seconds? 20 seconds have to be distributed as a delay between the two requests. So total 2 users only have to happen. So for only 2 users to happen, say for example, I will put this in another way. In a signal, when the green light comes, many might be waiting there. Our police guy decided that he will allow only 5 users. How he will allow? How much time the green signal will be? Green signal if it is there for 30 seconds. Your first user he has sent. So first user to go, he took says 3 seconds. How much time is remaining now? 27 seconds. Now how many he has to send? 4. So approximately now that 4 he has to divide among the 28 seconds. So 7 seconds. So with a delay of 7 seconds, he will allow other guy. But this guy to start and go, he took 5 seconds. Now 7 seconds plus 5 seconds, first 3 seconds. So 15 seconds gone. 2 users almost took 15 seconds. Now he will release another user. He has to go quickly. He will not give the delay. Immediately he will release. He will go in, say 5 seconds. So remaining 5 seconds. You understood what is happening here? He is controlling the throughput by changing the delay between the release of the users. That is the constant throughput timer. I think you can think. Okay. Still any doubts? Anybody? Or I am not able to explain you properly. Understand this. Hello?
Yes.
You got it, no? Over a period of time, I have to send this much set of requests only. So I have to send the constant throughput over a period of time. So based on the execution timings, I have to adjust the gap between the users so that I will adjust that many users over the period of time. Basically, over the period of time, this much activity only should be happen. From our data collection point of view, see between 9 o'clock and 9:15, only 50 withdrawals should happen. Even though I have sent 200 users into the field, but for my some analysis purpose, I want to have 50 transactions only between 9 and 9:15 a.m. Otherwise, what happens? More than 80, more than 100 also may happen because all are working parallelly. But I will somehow restrict them so that between 9 and 9:15, only 10 ATM transactions will happen. So I will hold others. That holding others by introducing delay, we do with the constant throughput timer. I think it is clear to you now. It is again controlling the activity. So we have understood the definition of timer is to control the rate of consumption of the resources in the system. So when I say 10, only like 15 ATM transactions in 15 minutes from 9 a.m. to 9:15 a.m. It means I'm controlling the rate of consumption of the withdrawal activity. Like this, for with Gaussian, with many other timers, you will control. Now, another timer is, you are convinced or not, friends?
So
Think.
my understanding is, so in our thread group, so there are total 25 requests. Okay. Because 5 thread group, and we have added loop count as a 5. So 5 into 5, 25. And here we are adding target throughput is in samples per minute is 2. So the total time it takes to 50 minutes, correct?
Somehow it
Because
will adjust in a minute, only 2 requests will happen. That's all.
correct. In a minute 2. So for all our 25 requests, it will take 12 minutes, 12 or 13 minutes, correct?
Approximately like that.
Yes. Okay. Thank you so much.
Including the execution time again.
Yeah,
Sometimes
yeah,
execution
yeah.
time will happen less or more. Based on that, this will
Yes.
adjust.
Yes,
But
yes.
sometimes it may not achieve.
Mhm.
Right? It
Got it,
depends
got
on
it.
the availability of the resources. If you say
Yes,
that
thank you.
resources are less, if you want to accommodate more, it may not be happy. It may not happen.
Correct,
This is
correct.
basically a goal-oriented scenario. So you
Yes,
also should have some idea about when setting this throughput. In load
yes.
runner, this is called goal-oriented scenario.
Okay, okay.
Now, coming to synchronization. Very important. In load runner concept, this is called rendezvous point. Here we are calling it as synchronization. Before understanding synchronization, we will understand the term timeout. Timeout is maximum time given to perform a task. Say, for example, to complete some test cases, say 50 important database test cases, you are given some 8 hours time. 50 test cases have to be completed. That is the target. So their timeout is 8 hours. If you complete this in 6 hours, it's okay. No problem. Another 2 hours we will be left with. But after 8 hours, if you have completed only 40 test cases, then only you have to stop. Then also you have to stop the testing. So maximum time given to you is 8 hours. Take another analogy. You are waiting for somebody to meet you in the reception. So after lunch, say courier guy or something like Blue Dart guy to deliver your credit card or debit card, he has come to your place. So he called you, you go into the reception and you will be waiting. So maximum how much time you will wait? Say you will give yourself, let's say 10 minutes. Because anyhow, you want to relax after lunch also. So instead of going a walk without going the walk with your friends after lunch, so you will wait. Maximum you will give timeout. This is called 10 minutes is timeout. So how you do this waiting? So you will go and sit and take some paper on magazine there in the reception. You will not immerse yourself in the reading. Say every 1 minute, you will check whether that guy has come or not. check for the guy. If he has not arrived, again you will start reading or flip the pages of the magazine. Again, after 1 minute, you will check. This is called polling time. Say 1 minute. Every 1 minute you are checking. Maximum you will wait for 10 minutes. Now, say in 4th minute that guy has arrived. 4th minute that guy has arrived. So you will take your credit card. You will not wait now for remaining 6 minutes. You will go for another your next task. You may go to your desk and you may join your friends walking. So maximum time is 10 minutes. Now take another case. After 10 minutes, the guy didn't arrive. You will not wait for him, right? He will go. So the maximum time to perform a task is 10 minutes. Within that time, if the criteria is met, you will not wait for the remaining. But after 10 minutes also, if the criteria is not met, you will proceed to the next task. That is the concept of timeout. Maximum time given to perform a task based on some criteria. Some success criteria. Some criteria, okay? Okay. Now, we would like to have spike in some activity. Sometimes we would like to perform some activity simultaneously by some set of users. And we have to perform this repeatedly in loops. Now, just by learning timers, we have understood we can hold the users to start the requests. But the completion time of the request and the response will not be in our hand. So the response time depends on many factors. Many factors which occur randomly. So starting is in our hands. I can say at 9 o'clock all should start. But the completion of some may finish this in 10 minutes, some may finish it in 11, some may finish in 9:12, some may finish in 9:09. That we will not be having the control. Now I want to go in loops. I want to start this activity together by 10 users. So I will have some limitations so that the activity will complete in 15 minutes approximately. So I will start all these users and they will finish and come back. So they have to wait for others to join. The criteria here will be, say all 10 users should arrive. Because my criteria is I want to perform some activities simultaneously by 10 users. Okay, by 10 users. So those users who arrive first, they have to wait for other users. How long they have to wait? I will specify the time. So here, all the synchronizations will have some policy, synchronization policy. So 10 users. Actually, total 50 users are running. Let us imagine total 50 users are running, right? But I want to create a spike of activity with 10 users. So what I'll do, I will set the criteria. 10 users should get released from the hold together and the timeout will be say 15 seconds. What is this for 15 seconds? So I have started all 50 users together, all 50, they will go because the criteria will meet. Because minimum 10 users should be there, 50 users are there, they go. And they will take different resources availabilities and they reach here. See what happened here? The first 3 users reached. What is the criteria? They have to wait for 10 users. How long? 15 seconds. So these users will wait. Say another 2 users join. So total 5 users are there now. So these 5 users will wait for another 5 users. How long? 15 seconds. You understood? The timer will be resetted. So first 3 were using, they are waiting. They will wait for 15 seconds. So within 15 seconds time, another user joins them and this all together wait for another 15 seconds. So within 15 seconds, if another 2 joins, these 7 users will wait for another 15 seconds. They are waiting and waiting. So nobody joined. 15 seconds timer is over. So these 7 users only will be released. This is the concept of synchronization point. But if you want to have 10 users, then you have to increase the timeout. You should know the availability of the resources, whether that in 15 seconds, can all 10 users join the pool or not? This is the pool. Okay, the pool of 10 users. This is the concept of synchronization. So what happens? Our requirement will be sometimes when 50 users are performing login activity simultaneously, 50 users activity simultaneously. See, only start I have the control, right? Starting login 50 users starting login activity simultaneously. At this time, I would like to measure time taken for withdrawal of amount. This is the scenario. That's the requirement. So when 50 users starts logging in activity, so the analyzer might have suspected that the resources allocated for login activity might be intercepting the withdrawal activity. So I want to find this, whether how much login activity will degrade my withdrawal. If this is the critical thing, so I have to somehow change my code, refactor my code, and these common resources which are utilized between withdrawal and login, something I have to plan. So more logins might be degrading the withdrawal because it is consuming the resources required for withdrawal. So I suspected, I want to check. So I will create this type of scenarios with the help of synchronization time. Okay, we'll do this. I'll take a new script. Add threads. Logic controller. Our next topic is controllers only. I will explain you the controllers. So now add one sampler HTTP request. I use blazedemo.com, and in the thread group I am having 30 users. Okay, Now, I will have a synchronization timer of number of simulated users by group by, I will say 10. Timeout. 5 seconds. What is the meaning of this? If when I start, if I start executing this, 30 users will start. Okay, and of course they might be doing looping also. So I'll say 3 loops. So total, of course, they execute 60 times that HTTP request. But what is the synchronization timer in this purview, in the thread group level? I want to release 10 users, right? Together, always. These 10 users, I will hold. How long I will hold? 5 milliseconds. Or sorry, I increase 5 seconds. Maximum time I am giving is 5 seconds, but this is not required. Okay, I will give 50 milliseconds. In 50 milliseconds, if 10 users arrive, they will be released. If not, also they will be released. Here you will get confused. So I have to increase the timeout. Let us see, run and see. I will add one. Basically, it is grouping. Now total 30 users. Okay. Yes. Sync time. Ten users were released actually. It's very quick. So what is the synchronization timer? 50 milliseconds. It is, they are coming. Okay. Now I'll run this again and see the effect. I'll do one thing. Let us introduce some constant delay. Timer, constant timer. 3 seconds. Synchronization timer is 50 seconds. Now see the effect. So every request will be given after 3 seconds delay will be there. Now see what happens. No user arrived within that time. So it is happening. It is happening, but we are not seeing the effect. I'll do one thing. Group. I reduce these threads to count. I reduce to 1. I will fail the criteria. What is my criteria here? 10 users should arrive. Okay. So I will write here in the, okay, in the thread group, 5 users only. Criteria will never met. What is the criteria? I have to wait for 10 users. So what is the timing I have given? 50 milliseconds. I will give now 5 seconds. Am I connected? I got some sound. Friends, I'm connected. Audible?
Yes.
Yes.
Yes, yes.
Yes.
Yeah. So timeout is 5 seconds. Means maximum I have to wait for 5 seconds for 10 users to arrive. My scenario doesn't have 10 users at all. So the synchronization timer hold those 5 users, expecting that other 5 users will arrive, because total 10 will come. After 5 seconds, they will be released. That is the meaning of this. Okay, let us check whether what we imagine happens or not. they are waiting. Now it's finished. Okay. So what has happened? After 5 seconds, they are released. They have not waited for 10 because 10 will never come. So they waited for 5 seconds. I will increase this timing. You got the concept, right? I'll give some 10 seconds. Even after 10 seconds, these 10 users never arrive. Okay. So the remaining 5 users who are there, they will arrive at in different timings because the constant timer is 2 seconds, 3 seconds are there. After 3 seconds, 3 seconds, these users, this is milliseconds, they will arrive. All are running parallelly, right? Don't imagine that sequentially 3 seconds. 5 users, every user, he will get 3 seconds delay. So there is a chance that all 5 users arrive at the synchronization point in 3 seconds. After that, they will wait for maximum, how many seconds? 10 seconds. Because what is the criteria? They have to wait for 10. 10 never arrives because in the group only 5 are there. So after 10 seconds, the 5 will be released. That is the criteria. You wait for a maximum of 10 seconds to arrive for 10, to pull up 10. But only 5 are there, but all 5 they will wait. It is like in schools, they will conduct picnics. You might have went to picnics, right? We know that only PT master will be in charge of this conducting picnics. So he might not be having other work of teaching. So principal will assign this job to the PT master. So he will be very strict normally. We know like he will be a joker and most of the times he will be very strict. So he will say tomorrow morning, 7 o'clock, everybody should be at the school ground. So out of 50 at 7 o'clock, 10 also might not arrive. We all know, right? So he will not start the bus and go with 10 only. He will say, we will wait for another 10 minutes. Whoever comes within 10 minutes, we will go with them. So in another 10 minutes, say 15 guys will come. Still, he will not go. What is the criteria there? He has to get maximum 50, maximum of 50. So he will say, in another 10 minutes, we are starting. Get into the bus. We will be playing in the ground. So we are 25. He will shout at us. You know how the PT master shout at us. So we'll 25, 30 guys enter into the bus. So he will say 15 minutes. So another 15 minutes, another 40, another 10 guys will come. So 45 are there. Now already it might be now 8 o'clock. So he will not wait for again indefinitely for other 5 people to come. So he will start the bus and go. So maximum of 50 is arrived and there will be timeout. He might have set the timeout before only. Maximum I have to start from here at 8 o'clock. So he will ask us to come at 7 o'clock. So that is the pulling up there. The number of users should arrive is 50 students, but maximum timeout is till 8 o'clock. 8 o'clock at any cost he has to start. Because if we delay, again the picnic will be spoiled. The same is happening here. Okay. So I'll replay this. So all might have arrived. No, 3 seconds over. Now all are waiting for 5 seconds. Then they will be released. Total 8 seconds. And you can have the synchronization timing at different levels, thread group level. But for now, make it simple. So we can have the synchronization timers at different levels, right? Okay. Now, each group can have different activities. And we can have the synchronization timer at the test plan level also. I can have synchronization timer at the thread level. Okay. I can have synchronization timer at the sample level. Now, if I want, for example, there is a login group and there is a logout group. I want to synchronize login 30, logout 20, and release. At that time, I would like to perform some withdrawal activity. So the login users all will stand at the synchronization point. Say our criteria is logins 20, logouts 10. So what happens if there is a script, say login activity and logout activity? So we will be having one synchronization point before login, one, with criteria 20 users. This criteria is another sync 2. This criteria is 10 users. So this I will assign to, say, some 30 users, 30 or 50 users are there. So all have started. So those who are at this login, they will wait, because before performing login, they have to wait. So 20 users, they will wait. Right? They will be waiting. Once they wait, once the 20 users reached this point, because before login, some other activities might be there, right? Connecting to the URL, then getting the login page. So some delay will be there. So these guys will reach to this login point in different timings. Once they reach 20, they will be released. Remaining 30 are there. Now they will come and stand here. That's a different thing. So these guys who were released at the login, they will come and wait at the logout. So some are now at the login because total 50 users are there. Some are now at the login. Some are now at the logout. So when this criteria of logins 20, logout 10, all will be released. So 10 users will perform the logout and 20 users will perform the login. At this point, I will measure withdrawal, for example. Withdrawal activity time. So here my objective is to know the effect of, right, login, logout, and withdrawal. So I would like to find the effect of login on withdrawal, effect of logout on withdrawal, effect of login and logout on withdrawal. So I can create this type of scenarios and I can measure. Okay. Now, just think, I'll give one exercise now. In Blaze demo, I think Blaze demo actually login is also there. / login. You get the login window. Okay. And there is password also reset. Password reset. Now create a scenario where 20 users should be logging in and 10 users should be resetting the password. Think and try to create this scenario. Okay. In blazedemo.com, www.blazedemo.com/login 20 users. www.blazedemo.com password reset. Okay, don't reset any password, just use do something. You check first, you have to understand whether it works or not. Give your email address. Okay, so some email address you try to give, whatever, nothing will happen. 10-20 users, right? And login. So you have to register first. Somebody will be give some registration also, right? Check whether simultaneous measure. Just explore now. You have to face the problems. Let us see. I want to have a scenario of login and password resets 10 and 20. Whether it is possible or not, it's a real scenario, right? Let us see what happens. Try. I didn't try it. I'm just giving you the exercise. You know how to create groups. You know timers. You know samplers, right? You know synchronization time. If you want to create a real-time scenarios, give some timers. Okay. Try to implement this scenario. Then after this, we will learn controllers. 5-10 minutes. You just try. Just try to imagine, try to apply what we have learned. I'll be back in 5 minutes. Okay. I'm here only. Just you try. Are you able to do, friends? I'll take a new script. Yes. Add thread groups. One thread group.
कौन-सा मुझे कर दिया ये?
Another thread group. Login group. Password reset group. Okay. Add simple controller. Okay. So login activity with sync. How much? How many? Sync. Login 20. This one. 10 users. Sync 20. Now here add sampler HTTP request login sample www.blazedemo.com/login. Okay. Now here add sampler HTTP request. I name this as password reset activity. Okay. Okay, password reset activity. This is this one. Password reset activity. www.blazedemo.com/password/reset. Do one thing. Let us add one listener view results tree, and these users, how many? Let us say 30 users, and these are 20 users. One user. Now I just run this. Okay. Sync login sync Blaze login password. Okay. Here, what is the scenario? What is the scenario? This group and this group together, they are running this many users, 30 users, and this group is running 20 users. Now we do one thing. At this level, we add one synchronization point timer. Okay, synchronization timer. So this should be 20 users. And timeout, let us give 500 milliseconds, half second. This is login sync of 20 users. Now, at this level, I add one timer, this one synchronization timer. Let us name this as password sync. 10 users. 10 users. Okay, 500 milliseconds. Now, up to here, what is the scenario? This guy will start 30 users. This group will start 20 users. But these 20 guys, they will come and wait here. And these two will come and wait here. Right? And our intention is they both should get released together. How many? 30 users. So what I do at the test plan level, I will have another timer. Another timer, synchronization timer. This is sync login and password 30. 30. Basically, I increase this to 1000. Let us see. Okay. Now these guys will be released. Once they reach 20, they will be released. Again, they will be released, but they will come and stuck here. 30. Okay. So 30 should be released like this. Let us see. This is what I am expecting. This group 20 will be released. This group 10 will be released, but they will come and stop here. So then 30, 20 plus 10, 30, they will be released. But you have to do some trial and errors, whether this 500 milliseconds, this 1000 seconds, whether the criteria can be easily met or not, how much time it will take for those users, whether these 30 users, based on the resources, whether 20 users can complete their transaction and reach here. Let us see. See, if we learn some logging and all, we can do this easily, but understand the concept. Because this login, nothing is there. Immediately they are coming. No need to have this 500 milliseconds also. To do that, what we can do, we will add a delay timer, constant timer. Constant timer of, I will give some 700 milliseconds. Okay, we'll give 2000 milliseconds. For this also, we'll introduce some. Add constant timer. Just introduce some delay. Some 1000. I could have added random timer also. That would be good. You should get an idea. I am just imagining. Clear and run. You can see now, see how they were released. Try now in the same lines. Friends, you are understanding how I am synchronizing. With different timers, I am achieving my goal. Different activities. Not easy like I am saying. You need to have a good understanding of what you want. Okay, repeat this exercise. Understand? Following friends, I am connected. Okay. We'll go to controllers. Just I want to give an idea. I can talk a lot about this, but for now it's okay. When we do some other exercises, we'll utilize this synchronization timing. Understand the complex concept and implement these timers. You may wonder, you may expect that only password and login should be there because they are released. So releasing will be in our hand. Completion will not be in our hand, right? Any questions up to here? I'm changing the topic. I'm going to controllers. Any questions up with timers? So timers are to introduce delay. Okay. Why we have to introduce delay? Okay, I think you understood.
Yes.
Yeah. No. There is one setting in thread groups which you have not used. That is called ramp. Loop count you have understood. You have another box there, infinite. Infinite means the loop will be infinite. That is because we want to have some constant activity like login, logout, login, logout, login, logout activity. During that period, I would like to collect some data. So this login, logout activity will be constant. So I will make it infinite. So unless until I manually stop the scenario, that will be running. Okay. That is one thing. There is a ramp up period. In a real scenario, all the events will not happen at the same time. If you observe the entry of our employees into the office, you can see if the office starts at 9:30, the ramp up will be from 9 o'clock to 10:30. Slowly, one by one will be coming. Okay, so that is a ramp up period. Then after that, scenario will run for some time till 12:30. All will be working. From 12:30, again they will ramp down from the servers. They have to go for lunch. In between 11 o'clock, 11:30, 12 o'clock, between also, there might be a tea break. In some companies, some good tea will be available between some timings. Okay. So if I go, I will be going to Dassault regularly in Pune, Dassault. So there you will find tea in the evenings, 3:30, 4 o'clock in the parking. That guy will give us the tea. The tea will be available in the canteen, but we all will go for that tea. So from our work, we all ramp down quickly because the tea will not last for more than half an hour. So if the tea guy comes at 4 o'clock, we all try to ramp down at 3:45. So we have to go down the lifts there and we'll spend some time, have tea, and again we'll ramp up. Maximum half an hour, we finish our tea and come back. And lunch, ramp down and ramp up will be there. So to create these real scenarios, real-time behavior, we are having ramp up. Okay. And another thing is the servers capacity will be limited for initialization process. So if all try to log in at a time, system may break. We have to discuss more about this. What is this breaking up? What is this stress testing and all? We will discuss somewhere tomorrow or later. When we, after finishing learning the JMeter, we will discuss about what is load testing, what is stress testing, what is volume testing, what is performance analysis. Those things we will see that later. Now, sometimes errors may occur, sample error. If you remember, on the first day, I might have told somewhere in my discussion that performance analysis is not testing. Failure is not of our concern. For us, failure is a data. If sample fails, why it will fail? Not because of functionality. It may, in our case, this failure might be because of non-availability of the resource. So some timeout will be there. Always timeouts will be there. In HTTP request also, you have timeouts. See, you might not have observed. I'm showing you. You click here, basic and advanced settings are there. Click on advanced. Here, you have timeouts. You have implementations also. For different requests, you can implement normally Java HTTP client is implemented. This is the, what is the implementation? Browser implementation. Because we are not having browser here. So which implementation you want? Java implementation or HTTP client for implementation? Most of the times we use HTTP client implementation. Means some browser activities this program will perform. And timeouts are there. See, connect timeout, response timeout. Means when we try to connect to the server, we have to wait in the queue. Connections will be limited. So how long we have to wait in the queue? So I can specify in milliseconds. If I specify 2000 milliseconds, 2 seconds, within 2 seconds, if I cannot establish the connection, if I means the sampler, if the sampler cannot establish the connection, it will fail. Of course, if there is a loop, it will come back. And response also. After sending the request, I should get the response within this much time. This is not response time. Response means first byte. This before load time. Connection time plus latency, some processing is there. I got the response. After the start of the response, a lot of things will get loaded. That is a load time. After load time is finished, then I can say that is a response time. This is response. So I will have the timeouts here. Like the same for the threads also. Action to be taken after a sample error. Because of connection time, because of these timeouts also the error may happen. Or other reasons, our data which we have submitted might not be valid at the server. So the request fails. Or that URL might be wrong. That might not be existing. But here our objective is not testing. We are not testing whether our developer has coded correctly or not. Our developer, that functionality testing is over. This comes under non-functional testing. We all know performance comes under NFT, non-functional testing. So I'm not checking the code which implemented some specification. I am testing whether the resources are available or not under load conditions. Whether resources are available or not when this much activity parallelly happens. When whether I can perform 1,000 updations to records in 5 seconds or not. Volume testing. So my objective is different here. I'm not testing the code or the result of the code. So for some reason, because one more thing we have understood in our discussions, availability of the resources is random. Because many users are utilizing the resources. Sometimes I may get the resource, sometimes I may not get the resource. Sometimes I may cross the signal along with my friends. Sometimes I may get stuck at the signal. My friends may cross the signal. All right. So I may meet somewhere, but some delay, some synchronization will happen. My friends may go somewhere at some other before some other signal. They will wait for me. That is synchronization. And we all together again we will start. This happens when we all go in bikes to some location, mountain location, Munnar or somewhere. Our friends may get delayed, right? So for some reasons, they will stop there for smoke, cigarette or something. They would like to buy something. When we turn back and see, they will not be there. So we will identify a good spot and we will wait for them. When they reach us, we all together go. The same here, the real behavior of performing some activity together, we will implement synchronization. And here I want to highlight, we are not stopping our request when something fails. When something fails is data for us to analyze. Because something is failing because some resource is not available. So we will be very interested to know which resource is not available. When all requests are passing means there is no information in that. Because our intention is to find the bottlenecks. So our load might not have reached to the limits of the resource availability. So we have to design a scenario taking into consideration the capacity of our system resources. So we have to load. So here, if for any reason, if sampler error fails, what to do? Default is continue. We will continue, we will not break. We'll go in another loop or start next thread loop. Difference between continue and next thread loop is see, I am here. This is my script. Some activities are there. So our users, I have assigned this to say 3 users, first user, 2 user, 3 user. Each user is going in loops, 10 loop. Okay. Now, each guy is repeating this activity. Somewhere this guy in 4th loop, he may encounter an error. So that he may encounter an error here in 4th loop. So the question is what to do. Continue means he will try to continue this. That depends on your script. So because this failed, say this might be a server connection or API, failure happened here. So you can decide, you can continue because the following activity, if that is not dependent on this activity, then you can continue. But if the following activity depends on the success of this activity, then you can restart the loop from the error. From the error, you will restart the loop. That is the setting. Start next thread loop. Or if that error is very critical, stop the thread itself. Stop that user, you will stop. How many users you are running? 3. If this user encounters some error, you would like to stop him. One thing is you can continue. Another is to restart the loop, because 10 loops we have to. Otherwise, you can stop the user. All this affects your data collection. You have to think and brood on this idea. Stop thread, stop test itself. So we will come out of this total test plan. We will stop whole of the test. Stopping test and stop test, now there is difference. Stop test means something which executing, we will finish that and stop. We will not go to, we might be in between the fifth loop. So just somebody told me stop test. So I will finish my remaining activity in the fifth loop and I will stop. Stop test now means wherever I am, immediately I have to stop. These are the things. Note this, okay? Continue, stop and start next thread loop, stop thread, stop test itself. Stop thread means remaining users will be running. Stop test means those who are running, they will get the instruction that stop the test. Whatever they are doing, they will reach to a point and they will stop. Stop test now means irrespective of what they are doing, they have to stop. And this you have understood, number of threads, ramp up, loop count. Now, same user on each iteration. If you choose this, if any resources are downloaded in the previous iteration, they will be used. It is like same user revisiting the website multiple times. If I uncheck this, for every iteration, cache, cookies, everything will be cleared. He will be a new user. Thread is same. But if you want to simulate new users in every loop, then you have to uncheck this box. Loop, iteration, both are same words, right? Iteration and loop, both are same. Meaning is same, right? Loop or iterations. Okay. Another thing. Delay thread creation until needed. I don't know. And delay thread. We will see the help, right? What he says. Okay. Before that, specific thread lifetime. How long you want to run this thread? Means I can specify. I want to run this for 10,000 seconds. And every thread starts with a delay of some seconds. Means I will run this many, but with a delay of some seconds. 10 continuously I will run. Startup delay will be some seconds. I can choose some 3 seconds. So every thread will start after 3 seconds. This is to unclog the resource utilization in the beginning itself, because our intention is normally initialization activities take more time, more resources. So we can introduce startup delays. So how long you have to run? Okay. So there is infinite also here. You can run the loop infinitely. Okay. This is one thing. And now delay thread creation until needed. We'll see in the help what it is. I forgot or something. I just said. This document is best. No need to go for any other documents, right? This is continuously getting updated. Thread group. Delay thread creation until needed. If selected, threads are created only when the appropriate proportion of the ramp up time has elapsed. Okay. This is most appropriate for test with a ramp up time that is significantly longer than the time to execute a single thread. Mainly, this is in relation with the ramp up. So if you say ramp up period, some 50 seconds. Now there are only 30 users. So what happens? Automatically delay has to be added, because in 50 seconds, 30 users should come up. So I have to introduce some delays. So delay thread creation until needed. So automatically a timer will be added. That is the thing. But normal timers are inside the script. This is before starting the thread. Because here, more number of users. Say in 50 seconds, I have to slowly release the users, 30 users. In 50 seconds time, 30 users should go up. If I reduce this to 10 seconds, of course, all 30 will come. But if I increase this ramp up period, means it will be like this slope. If you draw, normally in LoadRunner and all, you will get a graphical representation. So it will be like this. So this is 5 seconds, 10 seconds, say 50 seconds, 100 seconds, 120 seconds. So if I want to ramp up till 50 seconds, users. So then I will run for some time. So continue for 1,000, 10,000 seconds. There is a setting we have seen. Then there is no ramp up down. There in LoadRunner, we have ramp up, ramp down also. This is ramp down. This is ramp up. So if this time needed is more, so we will introduce some delay until needed, because sometimes I have to hold the users. So 10 users are running, another 30 users, another 20 users I hold. Then these 10 users, they went up and they will stop here. So remaining also I will ramp up. So I have to delay, because in 50 seconds, I have to add 30 users. So sometimes, like, I have to hold them. Like I told you, the traffic guy, if he has to release only 5 vehicles in 2 minutes. So one by one, he has to introduce some delay between this, right? Same like that. Earlier, that was between the samples. This is between the threads. Okay, that's enough. That is the thing. So after ramp up, you can choose this, how many seconds it has to run. Okay. Startup delay seconds. I will check it again. Startup delay, it is not clear to me. If the scheduler checkbox is selected, one can choose a relative startup delay. J will use this to calculate the start time. See, a lot of things are there. If you have a requirement, if you search to satisfy that requirement, these many settings will help you. So there are other threads also. No, because I will explain you the other threads some other time, because the setup thread group is there, tear down thread group is there, model thread group is there, right? Oh, I will show you, because I want to start controllers. Okay. Let us have some introduction on controllers, because controllers topic will run for tomorrow also. We should have some introduction today. Now, we have understood samples. We have understood some loopings at the thread group level. We have understood the timers, right? We have understood the synchronizations. Right? Now, we would like to control the activity. Another important requirement is, many times I have written, we have to control the activity. So we have controllers. This is called logical controllers. Controllers to control the activity. Activity is nothing but samplers. From first day, we are using one simple controller. This is only to group the samples. And those samples in this group, they will get executed in the order they are specified. Executed in the order. Okay. Now we'll see. See, don't think this training is exhaustive training. It's almost introduction training only. So once you understand these topics, when you try to apply these features, then you will need some more inputs. So always, again, you cannot ask for the training. So understand the concepts and search on the Google, you will get a lot of inputs, right? So you should know like what you want to search, what you want to question. Okay. So simple controllers for just grouping, there is no such functionality. Loop controller. Already thread group looping is there. This is additional loop. We will do this. First, we will start with loop controller. Many controllers are there. Very important topic. Okay, timers, controllers. Okay. Yesterday, day before yesterday, we have seen config elements. Then, and another important is post processors. Okay. So tomorrow we will see, like we'll finish the controllers and we'll see post processors, or we will see in the next class. I think, I doubt tomorrow we will finish the controllers. We have if controller, for loop, for each controller, while controller. But internally, before to learn controllers, we have to learn some logging in, variables, all such things. So just to learn controller, we have to cover other topics also. We'll see. No. I think by now you have become familiar with geometry interface and how to create the scripts. It's easy. I have not explained to you till now. It's easy. If you once you understand the concept, it will be easier. You don't remember that this has to be added like this. You know this what you have to do. This is a simple controller I have added now. In this, I add one sampler. Let us name this as Blaze. Okay. Basic blazedemo.com/. Okay. Now, how many users are there? One user. Loop count, one user. Okay. Loop count, one user. Now we know that if I increase this to 3, add one view tree listener, run this. How many times it has to run? 3 times. This Blaze request will be made by one user only. Okay. What is this controller we are going to run? Loop controller. That's all. 3 times. Now I remove this loop. Now I add another controller, loop controller. I can add like this and I can pull this into this. See, I'm pulling. I can do this. But it didn't went. Let us see. Yes, now under this. You try practice this also. Or what you can do, right click, you can do insert a parent. Okay, now see in under simple controller, I'm having a loop controller. This loop I will make it 4. Now run this. Four. So each user, when he is executing the script, when he encounters the loop, whatever samples are there in this loop controller will be executed 4 times. Now I increase this to 3. Now how many times this request will be made?
12.
12.
Yeah, because this loop controller is 4 and thread group is 3. So every user, he will run the script. So when he encounters this, these 3 users, they perform this loop controller. So loop controller is 4. So every user executes this loop controller 4 times. So totally for this test plan, Blaze sample will be executed 4 into 3 times, 12 times. Implement this. So you practice in 5 minutes after adding how to drag and drop into another controller, right? And how to create a parent for the existing group of samples. So I will add one more here, add insert parent logical controller. I will add one loop controller. This loop controller is 2 times. Now what happens? This is one loop controller. Inside loop controller, there is another loop controller. So this loop controller executes 4 times and this will be executed 2 times. So this will be executed in for one user, 4 twos are 8 times, 8 into 3, 24 times this sample will be executed.
We are still unable to hear anything.
Friends, you are able to do?
Were you saying anything before this? Because we were
No.
not
I
able to.
just went outside for 2
Okay.
minutes. Yeah. Okay. Now you understand another controller. For example, you have to understand how to use help also, right? There is one once only controller. Read from the help what is once only controller and tell me. Once only controller. See from the help what is once only controller.
So it only executes always during the first iteration of any looping parent controller.
You correct. It is not first iteration in whatever, because that first iteration and all again we may have logic. That will be executed. Whatever is there, whatever sample, whatever logic is there in the once only controller, that will be executed only once. Irrespective of any logic or irrespective of loops, whatever settings. Something like we want to start a server, we have to do only once for the scenario. Shutdowning the server, of course, this starting and shutting down we will do with other thread groups like tier group, setup group. I'm just giving you example. Something like I would like to log in only once and perform multiple activities. So that is once only controller. See, I'll have one controller here, and inside this loop controller, I will add one once only controller. In this, I add one sampler, HTTP request. I name this as only once Blaze. Okay. Sorry. Control X. Control V. Something like slash. Okay. So totally 24 times in this will be executed only once. Okay. So run this.
But I have a question here. So if the once only controller works like for a one-time activities, so why are we adding that inside a loop controller? Because it will run in that particular
Even
loop.
for that inside this will be executed only once.
Okay.
See, for example, I will put this at this level. Whole simple controller. No, only once controller. This, no. I will put this under this. So many loop controllers are there in this. What is the simple controller? Sorry, this I'll put here. So when we enter into this, it will run only once. I want to show you. It has to, for the whole scenario, it has to run only once. Okay. Here, I will put this here, and I will in 3 loop counts are there. Okay. So for the whole scenario, where it is simple controller. Okay. This has to get executed only once. Actually, 3 thread groups are there. It is now at the thread group level. Across all the users, this got executed only once. You have to observe that. We'll discuss more about scopes and hierarchies tomorrow. You will understand something more things. So now this is at the thread group level. See, what is the scenario first? Scenario is 3 users are there. All these 3 users were given this script. They have to execute all once, but there was internal communication between the thread groups by JMeter. When this thread has already executed by chance, other 2 threads, they are not Okay, sorry. So in the whole 3 times he is running. So in the 3 times he has once they have executed, somewhere it has blocked. Okay. So it has got executed once. Now I will do this again in the different way. Thread group level. I want to tell you. Okay, that's what I was just confused. I want to tell that at the test plan level, these controllers are inside the thread group. You remember that, right? The inside the thread group, not across the thread groups. Okay, inside the thread group, they can control the activity. That is the meaning of this. Okay, friends, we have many controllers like this, which we have to understand. But before that, we understand counters, we understand logging in, then we can execute and see easily the effect of the controllers. The controllers are very important topic. Okay. So we understand. Same here also, you have throughput controller, runtime controller, how long we have to run. Same like timers, where we introduce the timing. Here we will be controlling. So many if controllers are there, while loop controllers are there, right? While loop bit tricky, and for each controller is there. Switch controllers are there. Many things are there. We have to understand all this. So tomorrow we will try to cover with exercises these controllers. Okay. See, in between we will be learning counters, how to variables, because with variables, with the reportings, we can understand more these controllers. Okay. So any questions? So the homework is you have to understand precise timer, precise throughput timer. That is exercise, because I was instructed that some exercises have to be given to you. So understand. Okay. From JMeter help, understand the precise throughput timer. Okay. Compare this with constant throughput timer. Throughput timer. Imagine some practical real scenario where this can be. Search on the Google. Okay. Homework, right? Task. So search, think about this. What is this precise throughput timer? Because you have some introduction on timers. What is constant throughput timer, right? And how practically where we can use such many documents, something will be there. Try to explain me what is this. Okay. Tomorrow morning, first 5-10 minutes we spend on this. Then we proceed with the controllers. Okay, friends. Any questions?
Nope.
Others?
No.
Yeah. Okay. So we'll continue tomorrow. Okay.
Okay. Thank you.
Okay, friends.
Thank you.
Thank you. Bye.
Bye.
Yeah. Yeah. Bye.
Thank you.